Hi, welcome you all on Physics Addhyan. So in the last lecture we were studying the spherical polar coordinate system, and we were here that we have calculated these scaling factors 1 r and r sine theta, and stated this what u1 u2 u3 are and what e1 e2 e3 are, and we just wrote down these three unit vectors, that is r cap, theta cap and phi cap, and we calculated one, that was r cap, and you will find it here, that find r cap, and we did this one, and there was a homework for you, that was to find out or verify this theta cap and r cap. So I did this, that r cap is r vector by mod of r vector, and you find out this. So today we are going to discuss these three unit vectors in detail. In detail, I mean today we are going to derive all these three unit vectors in general, what we have discussed. So stay with us. So today's task is to derive, or not to derive, just to calculate r cap, theta cap and phi cap using general formula of calculating unit vectors. So hope you have remember these three formulas which we have calculated, that E1 is equal to, okay, let me go up where I have written those, E1 E2, it was just the starting, so yeah, where it was, no, this one, yeah, where this E1 was the unit vector, it was del r by del u1 h1, del r by del u2 h2, so same we will use here. So your E1 was del r by del u1 by mod of del r by del u1, your E2 was del r by del u2 by mod of that del r by del u2, sorry, mod, and your E3 unit vector was del r by del u3 divided by mod of del r by del u3. And in a spherical polar coordinate system, we have seen that your r vector, if I write as in Cartesian, that is xi cap plus yj cap plus zk cap, and your x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, and your z is equal to r cos theta. So let us substitute that in this vector form. So r vector will be turned out to be r sine theta cos phi I cap plus r sine theta sine phi j cap plus r of cos theta, and this is k cap. So this is your basically this vector, that is r, and we have discussed that our u1 is equal to r, u2 is equal to theta, and u3 is equal to phi. So let's calculate this E1, and we have also calculated that the E1 is r cap, E2 is theta cap, and E3 is phi cap. So let's do it quickly so that we can move further. So first, if I calculate r cap, so this will be del r by del r vector by del r by mod of del r vector by mod del r. So let us calculate first this quantity. So the first quantity will be, so if you, let me go a little bit up. So if you differentiate with respect to, will get sine theta cos phi I cap plus sine theta sine phi j cap plus of cos theta k cap. So this is your this quantity, and you have to take the mod of this. So its mod will be sine square theta cos square phi, if I took the under root first, the square, and add all these terms into sine square phi plus cos square theta. So take the common sine square theta from here, you will have cos square phi plus sine square phi, this is 1, so you will left with sine square phi, and this cos square phi will get you 1. So your r cap is basically nothing but this quantity. which we have discussed in previous lecture also. So today's task is to calculate theta cap and phi cap. So second one, your theta cap will be basically your del r vector by del theta by mod of del r vector by del theta. Okay, so let us calculate the del r by del theta from here. So if you differentiate with respect to sine theta, it will give you cos theta. So I am writing a little bit faster, cos theta cos phi I cap plus r cos theta sine phi j cap plus sine cos theta differentiation is minus of sine theta k cap. And now you have to find the modulus of this. So in modulus, this quantity will be your basically under root of r square cos square theta cos square phi plus r square cos square theta sine square phi plus r square of sine square theta. So here take r square common from everywhere. So this cos square theta you can take common. This and this will sine square theta plus cos square theta will become 1. So you are left with r square cos square theta plus r square sine square theta. This is under root of r square. This is nothing but r. So your theta cap will be this r will divide from everywhere. So you are left with cos theta cos phi I cap plus cos theta sine phi j cap minus of sine theta k cap, and this was the expression what we expect to get. So this is your theta cap. And similarly one could find phi cap, that phi cap is del r by del phi by mod of this del r by del phi. So this was the thing which we have derived in most general case. So if you differentiate that x part that contains cos phi, so this will give you minus r sine theta sine phi I cap plus, and the second term you will get is there will be a sine, so it will become cos, so it will be r sine theta cos phi j cap, and in z cap there was only z r cos theta, so it will give you 0 k cap. And now you have to find the modulus of this. So modulus of this, so modulus of this quantity del r vector by del phi is nothing but under root of r square sine square theta sine square phi plus r square sine square theta cos square phi. So this you can take common. So this sine square phi cos square phi will become 1. So this will be under root of r square sine square theta. So this is r of sine theta. Okay. So if you just divide this by its modulus, you will get minus this is minus sine phi I cap plus of cos phi j cap. So this was the phi expression which we expect to get. So what I suggest you to remember these unit vectors. Even it is not very difficult to remember, because if you know x, y, z, that is r sin theta cos phi, r sin theta sin phi, and z is equal to r cos theta, then you can simply you can stay with your equation for 5-10 seconds, then you can write r cap theta cap phi cap, because when we were dealing the surface integration or the line integration, then you will need to convert these theta r theta phi in I j k caps. So it is emphasized you to remember all these things or how we get these things, and you should always remember the general form of this unit vectors. So we are done with the unit vectors. Let's go further on spherical polar coordinates. Before going to next, let me introduce a matrix representation of this. So if I have a vector, let's say it's an ax I cap plus ay j cap plus az k cap. The same vector you can, this is written in Cartesian, so it is in Cartesian. Same vector you can write as an ar r cap plus a theta theta cap plus a phi cap. This is written in spherical. So there is a relation in between I, j, k and r theta phi, which I just discussed right now. So your r theta and phi cap can be written as some matrix that is multiplied by I cap, j cap and k cap. So what the matrix is, remember the terms with I cap was sin theta cos phi plus of sin theta sin phi and cos theta. Similarly, this was cos theta cos phi cos theta sin phi minus sin phi, and this was minus sin phi cos phi 0. Okay, so let me call this matrix as M. Okay, so your this equation will become your spherical polar coordinates के your unit vectors is equal to some matrix M, and your Cartesian, let me write it as C. These are 3 cross 3. This is a 3 cross 3 matrix, this is a column matrix, this is a column matrix. So if you want to find C vector, so this is nothing but M inverse of S cap. And if you hold on, and you can see that this is an orthogonal matrix. Orthogonal matrix. And we have discussed in the chapter matrices, then for orthogonal matrices, M trace is equal to M minus. So you just have to trace this matrix and you will get the C. So the trace will be, this components remain here, this component will come here, this component will go here, this component will come here, this component will give me just the transpose of the rows and column, and you will get this M transpose. So that was the power. It is a rotation matrix, so it is generally the rotation matrices are orthogonal, so you can apply these properties. That's why I emphasized you to study matrices first. Okay, so now let's move further. So now it turns to be in let's say in diagrams where we will see these r theta and phi caps. So let's see in diagrams or in pictures. So consider a coordinate system. Let's say this is x, this is y, this is z, and we specifically we are talking about the spherical coordinate system. So let's see the curves one by one. Let's say the first curve is R curves. So R curves start from this origin, that is at O, and that goes radially outward. So this vector is your R curve, this is your R curve. Let me use another color. This will is your R curve. In every direction it is pointing outward. So these are all straight lines. Even my hands are not making it too straight, so these are called R curves that originates from the center and goes outward, and so these are radially outward direction. So their limits are from 0 to infinity. So these are their limits. So this was the basically first curve we have seen, that is the R curve. Now let us see the theta curve, how it look like. So let us see the second one, that is the theta curve. So let us consider again a coordinate system x, y, z. This is your origin O. So at this, when you are considering the R curve, you have to take for R curves, when we have the general definition of curves, we have put the other parameters as constant. So for a particular R curve, you have a particular theta and phi that are both are constant. So for this curve, R and theta and phi is constant. For this curve, theta and phi are constant. Even the values are different for theta and phi. For this curve, theta and phi are constant. So if you want R curves, put theta and phi in constant, you will get a line, and you will get its limit, that is 0 to infinity. So similar wise, if you want to curve and theta curve, you have to put R and phi as a constant. So if these two quantities are constant, now let us draw the curves. So the first curve, let puts the R is equal to constant. So theta is variable, okay, and theta is basically our this vector. So let's say this R length of this vector is constant and your theta is constant, and its, let's call its projection on y axis, that is the angle phi, this is constant, when you change the angle theta, what you will get is basically what I was discussing. It will come out to be a disk. Okay, so this will be your something structure will be like this. So this is your increasing direction of theta. So this is your theta direction. So, and this is your the tangent to this is the direction of theta cap. So these are called theta curves. So these theta curves means if I take a point P here and make a projection, it will fall on this line. If I take another point here, if I take a projection, it will fall here, because for these curve this phi is constant, this angle is constant. So every point on this theta curve, if it's you take a projection, then the angle that projection connect that to this origin, that angle should be phi. Okay, so these was the two, that theta curve and phi curves, r curve and theta curve. Similarly, if you want to draw phi curve, then you have to put r and theta is equal to constant. So third thing is your phi curves. So if you want to draw a phi curve, you have to put r and theta as constants for a particular phi curves. So let me draw the coordinate system first. Okay, it's not selecting, what happened? Okay, and there will be one more axis, let's call it as x. This is y, this is z axis, and this is your basically your origin. So first you have to fix the radius, and the second you have to fix the angle theta. So at particular angle, let's start at the 0 plane where the theta is equal to, let's call theta is equal to your 90 degree, and your r is something. So it is a constant, this is a constant. So then when you will move around, okay, your theta direction is this, so you will trace a circle on the xy plane, and this basically these directions, if you call, so these are the phi cap directions which we just derived. So these are the phi cap directions at different values of phi. See, r is everywhere constant, theta is your 90 degree, but your phi is basically changing. So this angle you made with x-axis is phi, so it is going round and round in this direction. So let's make this theta to another value, let's say pi by 4. So it will be some radius like here, so it will trace a circle here going in this direction, going in this direction. So this is also a phi curve, this is a phi curve. So at particular r and theta you will get a phi curve. For constant r and theta you will get a phi curve. Now we have claimed that we are studying curvilinear coordinate system. So for those, your r cap, theta cap and phi cap should be perpendicular to each other. So let's see, is that the case or not? So same situations are here. Consider a xyz coordinate system. There is a origin O, okay, and basically this part, this curve is your theta curve. If I am at a specific r and phi, so that is your theta curve. So let's see the argument of r theta phi, the perpendicular argument or the orthogonal argument of r theta phi by picture. So consider that your r is equal to some constant. So let us consider at in this particular direction in y cap, so that you can see that even if r and theta and phi are constant. So what I am taking is r cap is some r j cap. Okay, so your r cap will be in this direction. So my radius vector is this, and this direction is my r cap direction. Okay, now let's see the theta cap direction. So at particular value of r, let's say this is the value of r, okay, this radius, and this and phi is equal to, let me take phi is equal to pi by 2. So from x axis we are on this y axis, so theta cap will be in this direction. And the third thing is phi cap. So let's take r is equal to r is constant. Let's take theta is equal to also pi by 2. So the plane which is phi curve is just this one which we have just discussed, and this will be in this backward direction. So you can see their r cap, let me this one, your r cap is in this direction, your r cap, your theta cap is in downward direction, so r and theta are perpendicular, and your phi cap is just going negative of x cap, okay, at this particular point P. So from here you can see r cap, theta cap and phi cap are even perpendicular, or better word is orthogonal. So these are orthogonal coordinate system. We are dealing in orthogonal coordinate system, which is very clear from this pictorial form. So if they are in orthogonal curvilinear orthogonal system, then they must hold this types of relation, that r cap theta cap is phi cap, your theta cap cross phi cap is equal to r cap, and your phi cap cross r cap is equal to theta cap. So this again I am using in right-handed coordinate system, right-handed coordinate system. Okay, so this was the thing. So now we have studied what the r, theta, phi, its limits and everything. Now let us go to the line element, surface element and volume element. So now let's study one by one. So the first thing is the line element, and we know that scaling factors h1, h2, h3 are 1 r sine theta. So h1 is equal to 1, h2 is equal to r, h3 is equal to r of sine theta. Okay, so the first thing, let's me call it as A, that is along r curve. So along r curve, let me call it as dlr vector. So this is the line element along r curve. So this is simply a small displacement in the r curve in its direction, that is r cap. So this is basically nothing but, let's me call it as x, y, z. This is the origin, and you have a vector, or sorry, r curve here. So if this distance is your r, and let's me call it a small displacement from here, and let me write it as this distance is r, this is r plus dr. So the vector that connects these 2 points is this. So this vector, small vector, this small vector will be dr r cap. So the same argument which we have studied in Cartesian coordinate system, so using that argument, this is this. And now let us see the second one, B, that is the along theta curve. What is the line element? So let's draw the picture first. So we have studied that this was our coordinate system x, y, z. Let's first draw the r curves. The theta curves, how it look like. So for a particular value of r and phi, you will get this types of curves. That is the, let me connect like this. Okay, so your theta cap direction was this. So your dl theta vector is equal to line element along theta curve. So what its value is, that's direction will be theta cap. So what's the value is? So let's call this as some at particular angle theta. Let's call this angle as theta. Let's call another angle from here, that is theta plus d theta. So this angle, yellow wala angle is theta plus d theta. So that makes an arc in this theta curve. So this distance is, you know that angle is equal to arc upon radius, angle is equal to arc upon radius. So this AB arc length, so AB arc length will be angle, that is d theta, into radius, that is nothing but r. So it is r d theta. So this is r d theta. So the line element is r times d theta. Okay, so this was along the theta curve. let's see the third one, that is your r curve theta, and that is along phi curve. So again similar concept, by using this we have to find the direction in which the phi curves varies and its element. So let us took the simplest case, that is of this one, the origin x, y, z. So there was a point in a space P, let's call its vector as r. There then we took an projection on xy plane. Okay, then the angle made was phi. So this length was r sine theta, because this angle was theta. So this component was r cos theta, this component was r sine theta. So this component is r sine theta at particular angle phi. So if you move this angle from phi to d phi, so this angle is basically your d phi. So this from this argument, this will become r sine theta d phi. Okay, so the angle along phi curve is dl phi vector, that is line element along phi curve is nothing but r sine theta d phi, and the direction is phi cap. So that was about the line elements in the r, theta and phi curves. So hopefully you have get these. Now let us move the surface element. Okay, so the second thing is we are going to deal with surface element. So basically when we consider the surface of the sphere or the spherical coordinate system, we are mostly or generally interested in theta phi curve. Okay, so if we have a sphere, if we are in cylindrical coordinate system, then the surface of this, we are more interested on the surface of this element, because every time when you are going to deal with surface integration, you are going to do a surface integration over the surface of the sphere or some spherical object. So surface integration on surface of a sphere or hemisphere is a part of a sphere, you can treat like this. So we are more interested in ds theta phi vector. So this will be similar with dl theta cross dl phi, and its normal vector n cap. Again there will be a problem in n cap, so we will just do. So your dl theta will be r d theta, so and your dl phi will be r sine theta d phi, and your cross product phi theta and phi will give you, and when you take it modulus, that r will cancel out because you have to tag the mod, and this is n cap. N cap is a perpendicular vector from the surface. So consider if you have a sphere, so let me write it here. So the surface element is r square sine theta d phi n cap. So this is your ds theta phi surface element. Okay, so consider you are on x, y, z, and there is a sphere that is solid. Okay, so for solid spheres, when you talk about the n cap, so that is, here will be your some surface element that is given by this, and the direction that is perpendicular to this is n cap. So basically it, in this case, it will turns out to be your r cap direction. If you have surface element at this cap, you will have the normal component as r cap here. If you extend it, this will be your basically n cap is equal to r cap. So when it is a solid sphere case, so but that will not be the case everywhere. Suppose you are on a hemisphere, so let me draw x, y, z, and you are, suppose you are on a hemisphere. Okay, so there is a basic, this one, and this is a hemisphere. My drawing is not going too good, but I hope you can understand it. So if we are on here, that is the surface element upper part, So its normal will be in this direction, that is given by the same r cap. If you are at this point, your normal will be given by this, that is the same r cap. But what happens when you are at the lower surface, that is on the xy plane? Then the normal will be this direction. So at this time, n cap is equal to minus of k cap. So you have to very careful about and on what surface you are going to do the integration. Or let us see one more case. Suppose you are on xyz plane, xyz axis, and there is a spherical shell. So there is one shell, okay, and this is the volume, that is not shell but a thick shell. This is the volume that it covers. So when you are integrating this inner surface, then the radial vector you have to take that is outward of the volume. So here n cap is equal to minus r cap. If you are on the outer surface integration, then you have to keep n cap as plus r cap, that is outward of the volume. So you have to always care about the signs of this n cap. So be careful, or if you draw the diagram, then it will be very clear that see, this is the volume. So the normal vector will be always away from the volume. So this will be in r cap direction for outer surface and minus r cap direction for the inner surfaces. So quickly let us finish the topic by volume element. So this is volume element of spherical coordinate system. So your dv volume element is nothing but dlr dot cross product of the other two, cross of dl phi. So your this will give you just calculated r square sine theta d theta d phi, and theta and phi cross product will give you r cap, and this will give you simply r cap, dr r cap. So this dr and r cap with this dot product will r and r cap will become 1. So your volume element is nothing but r square sine theta dr d theta. Sorry, I'm very sorry for this vector sign. This will be not a vector because volume element is a scalar quantity. So you can take this. So dv is r square sine theta dr d theta d phi. So that is your volume element. So till now we have discussed about the general coordinate system, its line and surface and volume elements. Then we move on to Cartesian coordinate system. Then we move on to spherical coordinate system. Now the turns comes to be on cylindrical coordinate system. So in the next upcoming videos we are going to deal with cylindrical coordinate system. Then we will define the most general expressions for gradient, divergence, curl, and your Laplace operator. Then we will find, using these general operators, we will find gradient, divergence in all these quantities in Cartesian, cylindrical and spherical coordinate system. And then hopefully then we will start the line, surface and volume integration and the other vector algebras. Okay, so thank you, and if you like these videos or you are getting something, then don't forget to subscribe the videos. Thank you.